Okay, this is a solving the systems of linear inequalities. So we're going to be graphing two or more linear inequalities with the same variables. And what we're going to do is some shading, and we want to see where the region overlaps, and that's going to be the solution. So when we graph our lines, if you see inequalities with a greater than or less than, it's going to be a dashed line. If you see a greater than or equal to or a less than or equal to, it's going to be a solid line when we graph them. And we're looking to see where they overlap. And that's going to be the solution to the linear inequality system. So here's our example. We have two linear inequalities, and we're going to ignore the inequalities for now and just graph them as lines and then do our shading. So here's the top inequality, y less than 1/2 x minus 3. So imagine this as a linear equation, y equals 1/2 x minus 3. The 1/2 represents our slope, and the -3 represents our y-intercept. So let's go ahead and graph that line. So we're going to go down 3 on the y-axis, and then up 1, right 2 to find all of our points. So up 1, right 2, up 1, right 2, or down 1, left 2. So there's some ordered pairs. Now we're going to go ahead and figure out, do we need to do a solid or a dashed line? So up in our notes here, if we have a greater than or less than, it's going to be a dashed line. Now we need to figure out where we shade. So let's go ahead and read this inequality. Right here it's saying y less than. So if we look at this line and we shade, we're shading less than or below that red line. All right, now let's go ahead and graph the second inequality. Y greater than or equal to -x plus 2. So I'm just going to change that to a linear equation, -1x plus 2. So we identify the slope, -1/1, and the y-intercept is 2. So we're going to graph the line. So we're going to find those ordered pairs. So we're going to go up 2 on the y-axis, and then our slope is -1, so we're going to go down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1, something like that. Now we need to figure out, do we have a solid or a dashed line? So this is our greater than or equal to. So anytime it's greater than or equal to or less than or equal to, we have a solid line. Now we need to figure out where to shade. So this is saying it is greater than or equal to. So greater than, we're going to shade above, greater points, greater than. And then we see, where do the two regions intersect to give us one solution? So I'm going to go ahead and highlight that in this darker shading. And that's going to be the solution area, is where the two overlap. All right, second example. So we're going to start with this top inequality. It's not in slope-intercept form, so we have to convert it. So we're going to go ahead and subtract x from both sides. Then we have to divide both sides by -3. There is a problem. When you divide or multiply by a negative number in an inequality, the inequality is going to flip. So let's go back up to this slide. And when you multiply or divide by a negative, what happens, the inequality will flip. And that's what happened in this example. So when we simplify this, we're going to flip the inequality to be greater than. And now we reduce. 6 divided by -3 is -2. Negative divided by negative is a positive. And then 1/3 x. So this is y greater than 1/3 x minus 2. So we're going to identify the slope and the y-intercept. So the y-intercept is -2. Now we're going to go up 1 and right 3. Up 1, right 3. Up 1, right 3. Or down 1, left 3. Down 1, left 3. Now this inequality is not equal to. So we have to do a dashed line. Now we need to figure out where to shade. So this inequality is saying y is greater than. So we are going to shade greater, or all the ordered pairs above that are greater than that red line. Second inequality also has to be converted to slope-intercept form. So we subtract 2x from both sides. And then interchange the terms on the right side. So now our slope is -2 and our y-intercept is 1.5. So we're going to go up 1.5, so right about there. And then we're going to go down to right 1. Down to right 1. Down to right 1. Down to right 1, about there. All right. This is also going to be a dashed line because it's not equal to. And now we read the inequality. It's saying y is greater than. So greater than is above the line. Those are the ordered pairs that are greater. And now we see where do they overlap. So we darken that in. So all of the ordered pairs in that darker region are going to be solutions to that linear inequality system.